Good morning, this is Pythagorean triples. Pythagorean triples is based off of something when we didn't have calculators and people didn't feel like dealing with big numbers. So there are three of them that you should familiarize yourself with. It's the 3, 4, 5. When I draw a right triangle, I know that my legs are 3 and 4 and my hypotenuse is 5 because 5 is the largest number in the list. The next one is a 5, 12, 13 right triangle. I know that my legs are 5 and 12 because they are shorter than the longest, which is 13. And then there's an 8, 15, 17. Again, I know that the legs are 8 and 15 and the hypotenuse is 17. If you memorize these patterns and can recognize when they show up, the amount of math that you would have to do to work the problems out decreases quite a bit. You can always use Pythagorean theorem. You don't have to use triples ever. It will help you to do triples. And triples are based on scale factor. And what I mean by that is if I have a right triangle and I have a 10 here and an 8 here, and it's a right triangle, this is 10 and I'm going to factor it and I'm going to say, hey, that's 5 times 2. Oh wait, that's 4 times 2. Oh, that's 3 times 2, which is 6, so that missing side would be 6. That's how you utilize those to find your missing piece. In fact, yesterday you did a paper. I did a practice paper, and I had you do the square. I had you do the square, use the formula, and today I'm going to use the same practice problem, and I'm going to show you by recognizing it what you could do. So I'm going to go through my thought process, and now instead of by formula, I'm going to do this by triples. And I'm going to list my triples 3, 4, 5, and I'm going to list 5, 12, and 13. And I'm going to list 8, 15, and 17. There's a list. The longer the list, the less frequent they appear. So if I'm looking for this, if I'm going to utilize my triples, I'm going to look at my hypotenuse, and it's 102. And 102 is not divisible by 5, so it can't be the 3, 4, 5. 102 is not divisible by 13, so it's not that one, but 102 is divisible by 17. In fact, that's 17 times 6. So I'm going to take this number and divide it by 6, and I realize that that's 8 times 6. Well, if there's my 8 and there's my 17, that has to be 15 times 6. There's my 8, 15, 17 right triangle, and 15 times 6 is 90. So this x is 90, and if you refer to the notes from yesterday, that's what we got. Okay, here we go again. 68, not divisible. It's a hypotenuse because it's opposite of the right angle. It is not divisible by 5. Not going to be a 3, 4, 5. It's not divisible by 13. Not going to be a 5, 12, 13. Divisible by 17. It actually is. So this is 17 times 4. There's my 17. I'm going to divide 60 by 4, and I get 15 times 4. Which that means this one is 8 times 4, which is 32. And that's what we got yesterday. So here I have a hypotenuse. Is it divisible by 5? It is. It is 17 times 5. I'm going to divide this by 4. and get 17 times 4. And then, so I have a 17 and a 17. That ends up to be my scale factor, so that's 17 times 3, which is 51. And so it's a 345 multiplied by a scale factor of 17. So on this one, I don't have a hypotenuse, so I'm actually going to check these numbers here. I'm going to check the littlest one first. So 72 divisible by 3, it is 3 times 24. When I check and divide it by 24, I do get 96 divided by 24 gives me 4, and so this is going to be 5 times 24, which is 120. So 3, 4, 5, 5, 12, 13, 8, 15, 17. This is divisible by 3, so that would be 3 times 4. This is not divisible by 4, so it is not a 3, 4, 5. This is not divisible by 5, so it's not a 5, 12, 17, or 13. And it's not divisible by 8. And I'm just going to give up and say not a triple, and I would have to work this one out by hand. So we have a hypotenuse, and this is 12 times 5. And then, because I'm always checking my 3, 4, 5. And then I'm going to take 36 divided by 12, and it's 3. Got my 3 and got my 5, so this is 4 times 12, which is 48. Now I don't have to deal with gigantic big numbers. I can just say, hey, that's a 3, 4, 5 right triangle by a scale factor of 12. Love hypotenuses that end in 5s or 0s because that will actually help me decide which one I'm going to, which triple. So this is 95. 95 divided by 5 is 19. I'm going to divide this by 19 and I get 4. There's my 3, there's my 4 and my 5. This has to be 19 times 3, which is 27, and that's what we had yesterday. Another nice one, divisible by 5. 15 times 5 is 75. I'm going to divide this by 15, and this is 15 times 4. I have my 4 and my 5. This has to be 3 times 15, and 3 times 15 is 45. So when you are working on your problems tomorrow, see if you can see if any of them are triples. If they are, here's what I would do is shown work. So if you have this, you can actually write it just like this, and that would be sufficient shown work. Or if you had a 10 and a here and you had an 8 and you put a 6 here, you would write triple 3, 4, 5 with a scale factor of 2, and that is enough shown work. If you didn't have this 6 and you went back to 10 squared minus 8 squared and you got 6, that is more than fine. Those are the two options of shown work. If it's a triple, you can annotate which triple it is and what the scale factor is. If it's not, if you can't see that it's a triple, then you can go ahead and do the Pythagorean theorem again like we did yesterday. Not acceptable is to say I did it in my head. Please show work and upload your work. Thank you.